Alright folks, we're going to do a rundown of the three major intermolecular forces that occur between molecules that are covalently bound. So between molecules. We've got three types and in increasing order. We've got our London dispersion forces. We also have our dipole-dipole. And then we also have our hydrogen bonding. And one of the problems that we might encounter is trying to figure out if a molecule is going to have dispersion forces, dipole-dipole forces, or hydrogen bonding as their major intermolecular force. And it's really simple to figure out which one's what molecule falls under each of these. And the rule of thumb is nonpolar molecules undergo dispersion forces, so they've got the weakest intermolecular forces, so they tend to be generally gases, but as we increase our molecular weight, those forces become a little bit stronger. So it's not unheard of to have liquids or even solids that are nonpolar, but for the most part, gases are. So examples of this would be our Brinkelhoff, so for instance, nitrogen. To figure out if nitrogen, the N2 molecule, would be polar or not, all we have to think of is all we need to do is draw the Lewis structure for it, and we see that all we have are two nitrogens together, and neither one of these attracts electrons any better than the other. So we have a really even sharing. So we don't set up a partial positive or partial negative side to this molecule. So that would explain nitrogen being a gas at room temperature, relatively lightweight, and it exhibits dispersion forces because it's nonpolar. Dipole-dipole tend to be polar molecules that do not have hydrogen bound to oxygen, nitrogen, or fluorine. So not with those guys. So it's got to be polar. So for instance, like I don't know, carbon trichloromethane. If we looked at this, if we put a carbon as a central atom and surrounded it by 4 chlorines, or 3 chlorines and a hydrogen, we would look to see what types of bonds we have. And it turns out we've got carbon to chlorine bonds as well as carbon to hydrogen bonds. If we looked at the difference of electronegativities from our periodic table that has electronegativities, we would find that the carbon to hydrogen bond is nonpolar because our difference is less than is 0.4 or less. But our difference of electronegativity is of chlorine to carbon is more than 0.4. I don't happen to have it in front of me, but we can look that up in our reference book. So therefore, that makes these bonds polar. And as we mentioned in class today, there was a flow chart. The questions that we have to ask to find out if a molecule is polar. The first one is there a polar bond? In this case, there is. The next question we have to ask ourselves is, are there lone pair electrons in our central atom? In this case, there isn't. That doesn't mean it's not going to be polar, though. The next question we have to ask ourselves is the central atom bound to more than one different element? In this case, it is. It's bound to chlorine, bound to hydrogen. So therefore, this is going to be polar. Because there's not hydrogen to oxygen, hydrogen to fluorine, or hydrogen to nitrogen, we stop at polar. And because it's polar, it has dipole-dipole forces. So that means adjacent molecules of this compound are going to be attracted to other molecules of this compound with polar bonds forming. Now, hydrogen bonding is a special type of dipole-dipole, just like a rectangle. I'm sorry, a square is a special type of rectangle. Hydrogen bond requires a molecule to be polar, so we kind of put it through the same flowchart we did before. Is our polar bond, lone pair electrons, bound to 2 or more different elements. And an example of this would be water. The last thing that we have to worry about is if it's polar, is there hydrogen bound to fluorine, oxygen, or nitrogen in it? And if it is, and the molecule is polar, then we're going to have hydrogen bonding. Oxygen, if we run down that flowchart, is there polar bond? This is definitely polar. The difference of electronegativity is pretty big. Lone pair electrons in the central atom, so it's polar. And we've got oxygen to hydrogen bonds. So that's a rundown of the different types. Good luck.